Hello, this is Jeff Hamrick at the Financial Analysis Program at the University of San Francisco. I would like to talk for a few minutes about doing probability computations related to chi-squared distributions and also calculations related to looking up critical thresholds for chi-squared distributions. So unlike the normal distribution or the student t distribution or the f distribution, there are actually two sets of functions that we can use in Stata for computations related to the chi-squared distribution. One of them does calculations from the left. That is, it finds probabilities, for example, from 0 up to a particular point. And the other chi-squared probability calculation function finds probabilities from the right. That is, from plus infinity on down to some particular point. Let me show you what I mean by that with a particular example. So if I use the display function and then chi2, and let's say we're talking about a chi-squared distribution with 13 degrees of freedom, let's suppose that I want the area to the left of the point 9. Okay, so 9 is on the x-axis. I'm integrating the area from 0 up to 9 underneath a chi-squared distribution's probability density curve. The value I get there is 0.227. Okay? There are actually two ways that I can proceed to compute the area to the right of the point 9 for a chi-squared distribution with 13 degrees of freedom. One thing that I can do is I can take the complement of this computation. I can do 1 minus chi2 13 9, and this computation will be the complement of the first computation. That is to say, the sum of these two numbers, this one right here and this one right here, add up to 1. Okay? There's another way I can proceed though. If I use display chi2 tail and I type in 13 and 9, I actually will get the exact same answer. So kind of idiosyncratically, Stata has two functions for chi-squared distributions, whereas for the student t distribution and the f distribution, to my knowledge, you have to read the probabilities in from the right. That is, from plus infinity down to some particular point. Okay, so there are two inverse functions that are analogous to chi2 and to chi2 tail. Okay, and those functions are the following. So suppose I want to find the point on the x-axis such that 5% of the probability mass underneath a particular chi-squared distribution is to the right of that point. I would use the inverse chi2 tail function. Let's say we're talking about now 8 degrees of freedom, and I want the area, the point that leaves 5% of the probability mass in the right tail. This would be the expression that you would use. So in other words, 5% of the probability is to the right of 15.5 for a chi-squared distribution with 8 degrees of freedom. Okay? If I would like to ask the same type of question for a chi-squared distribution but focusing on the left tail of that distribution, I would use an expression like this. I would say display inverse chi2, and I would say, let's say 8 degrees of freedom, and now I want to leave 5% in the left tail. Okay? So now when I use this function, I get 2.73, meaning to the left of 2.73, that is from 0 up to 2.73, we have 5% of the probability mass underneath a chi-squared distribution with 8 degrees of freedom. Okay, so there's a couple of extra functions here in Stata related to a chi-squared distribution. It's fairly easy to keep straight in your head. If you want to ignore the chi2 and the inverse chi2 functions and just focus on the chi2 tail and the inverse chi2 tail functions to sort of keep the story consistent with the student t distribution and the f distribution, I think that's fine. Good luck.